What's happening, everyone? Today we're going to build a tool in C# that allows users to search for text in specified file types. Ideal for searching for code, configuration settings, and code-related values you are looking for across multiple projects and solutions. It's not just limited to code, but this is the reason I built this tool. It processes, or if you want to call it, searches multiple files at once, and it's actually pretty quick. So let's get started. You can open Visual Studio. I'm using Visual Studio Community 2022. You can go and create a new Windows Forms application or whichever application framework you prefer. I've just gone with Windows Forms because I'm familiar with it and it's quick and easy to get up and running. So once that project is up and running, then add a new project of type class library to your solution. And you can call it whatever you want. I called mine logic. So this class library will contain all the methods and functionality required to perform the searches of the text. When I say the text, that's the search text we provide. I coded this class library so that it can be used outside of this solution. You could essentially import this class library into other projects if you wanted to as well, as it does compile to a DLL. So it's not limited to just this application in this tutorial. So let's continue. So now in the newly created class project, you can add two folders like I have. The first folder you can call implementation and the second folder you can call models. Let's start by creating our models in the newly created model folder. So we have several models, 5 to be specific. We're going to start now with the first model. The first model you can call base result object. So just create a new class file. This class is an abstract class that forms the base for our result objects. It contains a success property to indicate if the operation was successful, an error property to hold any exceptions that might occur, and a message property to hold any relevant string text that you want to either return back to the user or log or do as you see fit with. The next class you can now create is called findPassObject. This class is used to pass the search parameters. It contains the search text property for the text we want to find, the directory path, that being the property for the directory we want to search in, and the file extensions property for the types of files we want to search through. Next, we have the findResult object. This class represents a successful find. It contains the text find property for the text that was found, the file name property for the name of the file where the text was found in, the file location property for the location of the file, the line number property for the line number where the text was found, and the line location property for the locations in the line where the text was found. The next class object you can create is called findResults. This class is a collection of findResult objects. It inherits from the base result object and contains a foundItems property, which is a thread-safe collection of type findResult. And then finally, we have the generic result class, which you can go and create. This is a generic class that inherits from the base result object. It contains a result object property that can be of any type. Next, we're going to build our logic class, which will contain all the logic for the logic library. Our main class, which you can go ahead and create, is called findLogic. This is where the search operation is performed. It has a stop find text property of type boolean that we can set to true to stop the search operation. The first method you can see is called findText. This is where the magic happens. It takes in an object of type findPassObject, which contains our search parameters. There is also an integer passed to this method, which represents the degree of parallelism. This basically indicates how many files that can be processed simultaneously within the parallel for each loop. Once the method completes, it then returns an object of type findResults, which contains the results of our search. We also have two helper methods, getFileLocations and getInlineLocation. GetFileLocation gets the locations of the files we want to search through, and getInlineLocation gets the locations of the search text in the line of text passed to it. The code for the class the code for the entire class will now follow, containing the three methods just mentioned. To keep the video shorter and to force you to understand the code, please read the code comments as they are detailed and explain exactly what is happening. So here's the Windows Forms application for where I have implemented the logic search text class library. The design is straightforward. We have a file extensions text box which allows us to add the file extensions for the file types we only want to search within. You add the extensions via the add button. When adding the extension, it gets added to the extension list box control. Then after that, we have the select extension text box, which represents the text for the selected extension within the extension list box control. We also have a remove button, which allows us to remove the selected extension from the extension list box. Then we have the search text box control, which is where we will provide the text we are searching for. Then below that we have the location text box, which represents the folder path for where we will search its contents for the specified file types and the text we are looking for. To kick off the search, we have a search button, and then finally we have the rich text box control, which is where all the search results will be displayed for a search. Let me now run through this application so you can see it in action before quickly running through the code for this Windows Forms app. Let's now run through all the control events, starting with the Add button for adding extensions to the Extensions list box. When clicking the Add Extensions button, the following happens. We check firstly if there is even text in the Extensions text box. If there is, we then check if the text contains a comma. If there is a comma, we then split the text into a list and then iterate through the list. On each iteration of the list, we then check if the extensions we are wanting to add already exist in the Extensions list box. If it does not exist, we then add it to the list box. If there was no comma in the text box, we then simply add it to the list box of extensions. We then clear the text box. We then have the Extension list box select event for selecting extensions that are in the list box. On selection, we check if there are any items in the list box and that the selected index for the selected item is greater than -1. If this is the case, we then take the text for the selected extension and allocate that text to the selected extensions text box. We allocate the text to the text box in case we have a length issue and we need to see a longer text value, just for those wonderful custom extensions we may not be aware of, where a larger length of text is involved. Also keep in mind this Windows Forms app is just a sample, so the more visual the better. We then have the Remove button for removing selected extensions from the list box. So this event for the Remove button firstly checks that the selected extensions text box has any text in it. If that is the case, it then checks that the extensions list box contains any items in it. If there are items in the list box, the code then iterates through the items in the extensions list box, looking for the extension's text value that matches the extension's text box value. If there is a match, the code then removes the list box item, clears the selected extension's text box, and breaks out of the for loop. We then have the location text box. When clicking the location text box, we initialize a new folder browser dialog control and show the dialog control. From there, we wait to check when the folder browser dialog control select folder button is selected, which results in a dialog result of OK, which is simply an enum. If the result is equal to OK, we then take the selected folder path from the dialog control and allocate its text value to the location text box for viewing, and to also be used to pass that folder location onto the search text method. For the search text box, there is no action or event allocated to it. We simply just use the control to provide the search text for the search event triggered by clicking the search button. With that said, when selecting the search button, the following happens. We check if there is search text and if there is a folder path that has been selected by checking if the location text box contains any text. If that is the case, we then check if the location text box value ties back to a folder that exists and if there are any extensions in the extensions list box. If the folder does exist and there are extensions, we then iterate through the extensions list box and allocate each extension value to a string list, which represents all the extensions that were added. From there, we then initiate an instance of the findLogic class library. We then call the findText method in the findLogic class library, passing it a new instance of findPassObject, which we have populated its properties with the required values. As you can see in the code, we set the parallelism to 4, which will indicate to the findText method as to how many files it can process at a time simultaneously during the search process. Once the findText method is completed, we then validate the result returned and if it was successful, along with if there were any text results found. We then iterate through those results. For each result, we then add its value to the rich text box control, but we format the text via the add text bold method, which styles the text in the rich text box to make it easier to read. Let's now look at the add text make bold method. Firstly, it takes 6 parameters, the first being text1, which represents the label text, if you want to call it that, which simply describes the text following it as to what that text is. We then have text2, which represents the value linked to text1. So for example, text1 that has the text value of folder will then be followed by text2, which contains the folder path for the file that was searched. We then have text to highlight, which simply represents the text we searched for, which in some instances will be highlighted within this method's result in the rich text box, making it easier to read. We then have second text color, which represents the color that text 2 will be set to in the rich text box. We then have highlight color, which simply represents the back color for the text that will be highlighted. Then we have a bool property called highlight, which simply indicates to the method if the highlighting needs to take place or not. As you can see, the method is well commented, explaining what each line of code does. This now brings us to the end of this tutorial. If you have found this tutorial helpful, please consider subscribing and don't forget your free access to Ultrafine 5000. It's multi-threaded and really does help for searching code in my day-to-day job. So I'm sure it will help you. With that said, thanks for watching and we'll see you on the next one. Cheers.